here's an example for you to try. So this is a spinner, like in a kid's game, where you actually spin the spinner twice, and then you're going to add the two numbers together. Okay? And you're going to treat L like it's a 0. So if I spun the spinner twice and I got a 2 and then a 6, then I would move 8 spaces. Okay? But let's say I got a 4 and an L. Then that's like 4 plus 0. So I'd move only 4 spaces. And then if I actually get an L and an L, then I lose my turn. Okay? If you get L on both spins, then you lose your turn. So what you want to do is find the probability of losing your turn, find the probability of spinning a sum of 12, and then spinning a sum of 6. So you'll probably make a table like you did before, and just to help you here, give you a hint, is I would label this maybe L sub 1 with a little 1 subscript, L sub 2 and L sub 3, to treat them as different L's on the table. You don't have to put the subscript there, but you do want to have each of these individual L's on the table because they are individual spins. In other words, each one is an individual outcome. So go ahead, press pause and give this a try, and then when you're done, you can start it back up and see how you did. Okay, so let's go ahead. Let's see how you did. Okay, in this case, the spinner does have 6 faces, or 6 spaces on there. And so we're going to have a 6 by 6 table. Okay. And the table will have like the numbers 2, 4, 6, and then an L, an L, and an L. And you don't need to have L sub 1, L sub 2, L sub 3, but you do need to have 3 L's on your table. Okay, and then this would be 2, 4, 6, an L, an L, and an L. So you could think of this as spin 1. This would be spin 2. Okay, and so a 2 and a 2, that would be 4. This would be 6. That would be 8. And this would be a 2, a 2, and a 2. And this would be 6, an 8, and a 10. And a 4, a 4, and a 4. This would be an 8, a 10, and a 12. And a 6, and a 6. Okay, this would be a 2, a 2, and a 2. This would be a 4, a 4, and a 4. This would be a 6, and a 6. And then these would all be double L's, or I'll just say L for lose turn. And so your table would look something like that. So you would have 6 times 6 is 36 outcomes, just like rolling 2 dice. Okay, and then these different probabilities here, I'm going to write them down here. The A would be probability of losing turn. B would be probability of spinning a 12. And C would be probability of spinning a 6. And we can use our table now. So losing a turn, there's 36 outcomes, and these 9 here would be losing a turn. So it'd be like 9 over 36, which is like 1 over 4, which is 0.25. So in a sense, this is like 1/4 of the entire table. Okay, so 0.25. What about spinning a 12? So out of the 36, there's actually only that one case where you can spin a 12. So this is 1 out of 36. So 1 divided by 36. And that would be approximately 0.0278 if you round to 4 decimal places. And finally, spinning a 6. So it looks like you have these 2 6s, and you have these 3 and these 3, and so you would have 6 plus 2 more is 8, so you get 8 over 36, and 8 divided by 36 is approximately 0.2222. Okay, and those would be the probabilities. That's a nice problem there. But it gives you another example of doing a combination of 2 things and using a table like this to find the probabilities.